now let's have a look. That's the efficient frontier spreadsheet. And the same, we have the variance covariance matrix. I copied from the previous spreadsheet. And also we have the expected return here. And how can we calculate the efficient frontier? We know from the theory, the efficient frontier, let's have a look here. I have already drawn this graph. The efficient frontier is from your minimum variance portfolio to the upslope curve. So this efficient frontier is dominant than other opportunity set point on your graph. So which based on the same risk. So if we give the same risk, that point on your efficient frontier will give you higher expected return. So the point inside the opportunity set definitely will have a lower expected return. So when you invest, you definitely won't choose any point on the opportunity set, but except the efficient frontier point. So how can we draw this efficient frontier? It is based on our equation here. So as we mentioned, if you are given the same risk, so let's have a look at the graph. If we are giving the same risk, which means give the same expected return, which means here you have a horizontal line here. So if the expected return is the same, definitely based on risk-averse investor, definitely you will choose the lowest or smallest variance, smallest standard deviation. So based on this equation, let's have a look. If we give the same expected return, so this E is you give it to the portfolio. And if we give the same expected return, we want to minimize our portfolio standard deviation. So that's the aim for our portfolio. And the last one is the sum of the weight should equal to 1. So here in this part, we need to first set the weight for W1 and 2, W30, and we want to know what's the optimal weight for each individual stocks for all these 30 stocks. And we know how can we invest in these 30 stocks. We can give this give one expected return, and we will have the smallest portfolio risk. So the first step, you can give 1 to W1 and 0 to all the others. So we have all this weight set up by yourself. And then for this portfolio return, definitely it's the same way we do it by our in the previous opportunity set. Remember we use the weight. So now the weight, we don't use the computer to simulate. We just use here. So you select B36 to AE36. And then we will use computer to calculate the best weight for this 30 stocks. It will show you directly in computer. And then you use weight, multiply, the next one is stock return. So we use transpose and stock return on the top line here. So that's the same equation, and you run it using random matrix, Control Shift Enter together. So we get this result here. Control Shift Enter together. Okay, and then for the risk part is the same as I mentioned. We use square root and MMULT, and then you use the weight here, multiply variance covariance matrix here, and then you multiply the transpose of weight, and then you run it. So Control Shift Enter together. Okay, so we set up the portfolio risk, and then you need to set up the slope. So this slope is on your graph, that's capital allocation line. So that should be your portfolio return minus risk-free rate. So for the risk-free rate, we already gave it to you on the previous original data. So on the that's on return and covariance part. So you can have a look on the return and covariance part. We have our risk-free rate. So based on this is the daily risk-free rate, you can calculate the annual, or you can using the average of this daily risk-free rate, and then you can use it here. So we use, for this slope, we use the portfolio return minus our risk-free rate. The way I have over 250 is because this risk-free rate is the annual rate, and I just use divide by 250 to calculate the daily rate, and then we use the total to divide by the portfolio risk. So that's the slope for your capital allocation line. And the way we want to do that is, remember, for capital market line, that's the highest slope. So one way you can do is you can calculate the highest slope, and you can get the combination for all these stocks, and then you can know what's the portfolio return and portfolio risk. And then the next one is the constraints. For this constraints, it should equal to the sum of all these 30 stocks weight. So it's the sum B36 to AE36. That's the weight, the sum of the weight. All the condition we have already set up. The next one, we need to run condition and get the result each one by one. And if you get nearly 20 results, and then you can draw this graph. So let me show how can you do that. So let's go to the data part. So the data part, you click that and find on the right hand side there is no one called solver. So you click the data part and you have look on the right hand side, is there any solver? So there is no one, and we need to add in. So click file and you find there is called option, and then we can click add in. And then here, for add in part, we click go. And here we have different add in. So if we want to add in solver, so you click that. And if you want to do any analyst two package, you can click this one. But now we don't want to use it, so we just click solver and then click OK. So now the solver will add in your computer. Okay, the solver add in your computer. So you click data. Now you will have look here for the analyst 2 pack. We have the solver. So here you click solver, and it will come up with the solver parameters. So the first one we need to do, we want to maximize our slope. Remember, as I mentioned, the CML, the line CML, capital market line, which has the highest slope. So the first one, I want to maximize the slope. So for the set objectives, you can select this AH36. The cell AH36, which is our slope, and then you can choose maximize. So here you choose maximize part, and by the changing variable, and you select all the here all the weight. So for this 30 stocks weight, and then just reset all. So just delete here. Now let's have a look. For the subject to the constraint, we need to add one. So here, now let's have a look. One of the constraint is your sum of weight should equal to 1. So here we choose this sum of weight. So it's AI 36 and make it equal to 1. And then you click OK. You will see that this constraint add in your solver. And then if you invest in Chinese stock market, definitely we will have a short selling constraint. So you can't doing any short selling. The weight should greater or equal to 0. So you can add the weight for each individual stock should greater than or equal to 0. I don't have enough time, so I didn't add each constraint in your solver. So if you have time, you can do it by yourself. And after you add all the constraints here, and you can click solve. Okay, it will come up the solver result, and then we can click OK. We will keep this result. Now let's have a look at the computer directly calculate the weight for this 30 stocks, and for 牧原股份, we will invest 6.8%, and all these other stocks we won't invest, and the weight for each individual stocks is here. So we can get the slope. The highest slope is 0.0923, and the portfolio weight, portfolio risk has already given it to you. So after the solver find the result, you can copy the result, copy, and then you paste down here. So you paste here, like paste the number, and then click that. And this is the first step. We calculate the highest slope. So we know the CML line. We have the highest slope, the portfolio return is here, and then based on this portfolio return, we need to give the portfolio return as the constraint, and then minimize our portfolio risk, and then calculate the result each one by one, and then paste our result here. So let me show you how can we do the second step. You click solver. Now the objective is not to maximize the slope. Here we want to minimize the risk. So based on this blue part, remember, minimize the portfolio risk. So we select the portfolio risk and then select minimize. And the changing variable is also the weight for these 30 stocks. And the constraint, the first constraint is the same. We want the sum of weight equal to 1. And you can add the constraint for the weight, each weight is greater than or equal to 0. And then we need to add another constraint. Now, another constraint is here. Our portfolio return should equal what? So we given the portfolio return, we want to minimize the risk. So here we need to add constraint, and here we want the portfolio weight is equal to what? So this number give it to you by yourself. So the first one, let me see, I already calculated the largest slope we have, the return is 0.0016. So we calculate the minimized portfolio risk. And then you click solve. And it will give you a new result. And then when the solver get the result, you copy paste here. And the next one you need to give the expected return is equal to 0.0085. And then each one by one, and copy paste down. And just want to remind you the result you copy paste here, and it should follow order. So all the portfolio return should from the smallest to the largest. So that is important, from the smallest to the largest. Otherwise, you won't get the graph. Okay, it got the result here. We can have a look. That's the new result based on the portfolio return is equal to 0.00075, and we calculate the portfolio risk and also the weight for each individual stocks. So you can copy all this result down here. So it's exactly here the result like here. And also you do it each one by one, nearly 20 results. It was great. So here I use the yellow to denote this is the highest slope, and this result is the global minimized variance portfolio. So one is here and the other is the highest slope here, and this one. And after you do that, you can draw this graph. So you want to draw the graph, you insert, and here we select the scatter and with smooth line here, and then you can just add select your data. Add for the x-axis, remember, is our portfolio risk. So you select all the portfolio risk here, like here. Anyone, you can choose until the last one. And then for the y, we select, can remember here. Let me check. 58, yeah. And then you click OK. Okay, so you will draw this efficient frontier. But this graph is not as good as my doing, so you can change the style and you can change the color, and also let me see here, and you can change the x-axis, and the smallest point from x-axis you can begin from 0.014, like my graph. Okay, after that you can finish your efficient frontier. So from this minimum variance portfolio, the upper one is your efficient frontier. And then you need to draw your capital market line. So this line is your capital market line from the risk-free rate, and that's your market portfolio. So you draw your capital market line. The way you can do it is the first here, you need to write down your risk-free rate. So for the risk-free rate is here, the x-axis is 0, and y-axis, the risk-free rate is sorry, I can't find it, AH32. So let's have a look, AH32 here. That's your daily risk-free rate. So your daily risk-free rate, we can directly select here. And the second one, you can do it by yourself. That's your market portfolio. So the market portfolio is the one you have the highest slope. So it's exactly same here. So your portfolio return and portfolio risk here we already calculate, so you just write down here. And the next one, you can do it by yourself based on 2 point can get a line, so you put it on the let me see, you put it on the CML, this here. For the X, you select this one, and for the Y, you select here. Okay, so that's how can we draw our efficient frontier and capital market line. Here on the right hand side, you can have a look at this graph. We have plotted all these 30 stocks on this graph. So you can have a look at 贵州茅台、五粮液. They have a much higher expected return compared with other stocks. So compare with them, we can definitely have格力、美的 have a lower expected return but higher risk. So in that time period, definitely the 贵州茅台、五粮液 had a better performance. But if you're doing the portfolio construction and you invest in the portfolio, we can have a much better expected return compared with only invest in 贵州茅台 or other individual stocks. So that's the idea why we want to construct our portfolio and why we don't want to put all the eggs in only one basket. So this the idea from the mutual fund if you have a huge amount of money to invest. Okay, so that's the efficient frontier part.